Okay, so we are asked to solve this triangle with the given information. So it might be handy to make a quick sketch of this triangle. So let's see, where's my pen? There's my pen. So we're going to draw the flat side here, not so flat, and then a shorter side, and then the long side here. So this is the angle that we're given. A is 32 degrees. That means this is the opposite side A, because the letters are always across from each other. And if we know that B side is 18, that means little angle B must, or rather big angle B must be there. Okay, so we want to first see how many triangles can be formed before we apply the law of sines to figure out what the measure of angle B is. Because if there aren't any triangles, then we don't have to find anything. So the first thing we calculate is the height of this triangle so that we can compare the height to some other sides. Okay, and we find that the height is found by taking the adjacent side, right? This is now a hypotenuse of a little right triangle. So 18 is the hypotenuse of this right triangle times the sine of 32. And when we put this into our calculator, 18 sines of 32 is 9.539. Okay, so that's the height of this triangle. Okay, now we're going to compare to the height of the triangle to the opposite side. Okay, this will tell us, at least if we have any triangles that can be made. So notice the height is 9 and the opposite side to our angle 32. So 32 is our angle that we're talking about. 30 is the opposite side. So indeed, the opposite side is larger than the height. So we can figure out that at least we can have some triangles. Okay, at least one triangle, maybe even two. So then the second thing we look at to determine if it's one triangle or two triangles is we compare the opposite side and the adjacent side. Okay, so if we compare the opposite side 30 to the adjacent side 18, we notice that the opposite is larger than the adjacent, which means that we can only have one triangle be created with this given information. So now that we know there's one triangle, we're going to have to use the law of sines in order to solve everything about it. So we're going to find angle B, we're going to find the measure of angle C, and we're going to find the length of this opposite side down here, side C. So these are the three things that we need to find in order to solve this triangle. So let's do angle B. Okay, to do that we use the law of sines, which is a proportion. So 18 over the sine of B, because they are opposites. Right? 18 is little side B and angle B, so they go together. That comparison has to be the same as 30 over the sine of 32. Because 30 and 32 are opposite each other. So that's how we set up our law of sines in order to find the measure of angle B. Okay, so we cross multiply. 18 sines of 32 needs to equal 30 times the sine of B. Okay, so we can put this all in your calculator, and I'll do that in a second, but only after I divide both sides by 30. So 18 sine of 32 divided by 30. This gives me a decimal of 0.317952 equals the sine of angle B. So since we're trying to solve for a sine, since we want to find an angle, we need to get rid of sine, and we always do that by inversing. Anytime we're trying to find an angle using law of sines, we will always take the inverse at the end, the inverse sine in this case. And inverse sine of 0.317 means my angle B is equal to 18.5 degrees when I round to 1 decimal place. So we use the law of sines to calculate the opposite side or the opposite angle from B. And now we can find angle C. So we find angle C by using geometry. We subtract the other two angles from 180 because the three angles of a triangle add up to 180. Nothing too mathematically brilliant there. 180 minus 32 minus 18.5 gives me a C angle of 129.5 degrees. 129.5. So now that I know the angle across from side C, I can once again set up my law of sines proportion. C over the sine of 129.5 that I just found is equal to 30 over sine of 32. Okay, I always try to use the given values, right? 30 was given to me and 32 was given, rather than this 18.5, which I had to calculate. So if you use the given values, you're always going to be right on track. So we cross multiply here, and then we divide. And when we do that in our calculator, 30 times the sine of 129.5 divided by the sine of 32, I have a C length of 43.684 units long. Okay, and now my triangle is solved. I know all three things that were missing. I know my angles, my two angles, and I know my side length, 43.684. And my triangle is solved.